In section 1, we talked about how two different populations affect each other, specifically predator and prey. How if there's too much predator, you're not going to have enough prey, and if there's too much prey, you're going to get lots more predator, and vice versa. In section 2, we're going to talk about other factors that affect populations in an environment, specifically competition between populations, and how resources can limit the population size. So, populations all affect each other. They're also affected by the non-living parts of their ecosystem. And the second bullet here should be familiar to you. It says living things produce more offspring than will survive. That should be very familiar because we've seen it in Darwin's theory. That's Darwin's first part of his theory called overproduction. There's always more babies than can survive. So in Darwin's theory in natural selection, we learned that the best suited offspring survive. In this section, we're going to talk about what determines how many survive. And what determines how many will survive are the resources. There isn't enough food and shelter and water and air and soil or whatever for everything to live. There's only enough for a certain number to live. And of course, you know from natural selection that the ones that are best suited are going to survive. The factor that you run out of in an ecosystem is called the limiting factor. It limits the population size. Let me give you an example. Let's pretend you got a job working in a factory. And in this factory, you're in charge of making stools. So every day, this is what you build. You take 3 legs and a seat and you assemble a stool. That's your job. Now on Monday, you go to work, and on your workstation, there's 2 seats and 6 legs. How many stools can you make? The answer, I think, is obvious. You can make 2 stools. Each one has 3 legs and a seat, right? But what if on Tuesday you go to work and there's only 1 seat, but now there's 6 legs? How many stools can you make now? It should be obvious that you can only make 1 stool. You only had 1 seat. You ran out of seats before you ran out of legs. So you'll make 1 stool, but you'll have 3 legs left over. What did you run out of? You ran out of seats. So we say that the seats are the limiting factor. They limited the number of stools you could make. How many stools could you make? You could only make 1. We call the number 1 your carrying capacity. It's the number of stools that, in this case, that you could make. So how does this apply to an ecosystem? Limiting factors can be anything. Any resource that you run out of or anything that keeps a population limited can be a limiting factor. And notice a limiting factor is always a factor, something in the environment. It's never a number. It's always an issue in the environment. Predators, food, prey, floods, fires. These are limiting factors that can limit the size of the population. The factor that you run out of first determines your population size. So look at this. On this barrel, each piece of the barrel has a different resource written on it. So this piece of the barrel is air. And you can see there's lots and lots of air. And if air was the only resource we needed, we could fill the barrel up to here. But there's also water. And in this case, water only goes up to here. So if water was the only resource we needed, this is how high the population could be. But look at this. It says here that we run out of potassium first. Now, common sense would tell you that if potassium is the thing you run out of first, in this example, you can't fill the barrel higher than potassium. So the limiting factor is the thing that determines, we're saying here on this slide, yield potential, but that just means carrying capacity. It's the size of the population that you can hold. Carrying capacity is the largest population that an environment can support. Now, if your carrying capacity might be 7, maybe I can have 7 frogs living in this aquarium. Maybe your carrying capacity is 100. Maybe I can have 100 giraffes living in this zoo. But whatever your carrying capacity is, it's always a number. It's a capacity. Now, what happens if you go above your carrying capacity? What happens if there's enough room in your aquarium for 100 fish, but you have 107? What's going to happen? Now, in the case of fish, those extra 7, those 7 that are too many for the environment, they're going to die. They're not going to have enough resources. They're going to die. And you know from Darwin that it's the weakest that are going to die. If you were looking at something, let's say a giraffe population in a savanna, and you had 10 extra giraffes that could live in an ecosystem, those 10 giraffes, they might die, or they might move to a different region. So in some cases, If you exceed the carrying capacity, the extra organisms might leave, and in some cases they die off. And we say that the population eventually returns to the carrying capacity. So in the predator and prey lab, you saw populations that got very, very big with the hairs and very, very little with very few hairs, and very high, lots of hairs and then low hairs. And lots of lynx, 32, 64 lynx, and sometimes we only had 1 or 2 lynx. That's not usual. In the real world, your population would be maybe 100, and then 106, and then 102, and then maybe 94. They would kind of be around a very small area. The number of living things in an ecosystem usually doesn't vary dramatically. Usually only goes up and down a little bit at a time. If it gets a little too high, somebody dies or moves to a different location. If it gets a little bit too low, more babies can survive. Let's look at this example. Let's pretend we have a group of frogs. They live in a pond. The pond has enough food for 100 frogs, enough space for 50, and enough oxygen for 250. Now think about it. What's the limiting factor? When I ask for limiting factor, I'm asking for what's the resource that you're gonna run out of first. Well, you've got enough food for 100. We're not gonna run out of that first. You have enough oxygen for 250. You're not gonna run out of that. What you're gonna run out of is space, because you only have enough space for 50 frogs. So the limiting factor in this case is space. So what does that make the carrying capacity? If you run out of space first, what's the carrying capacity? How many frogs can live here? Remember, the most frogs that can live in an ecosystem before they run out of anything. So there's only enough space for 50 frogs. If there were 51 frogs living here, that extra frog is going to die. It's not going to have enough space, or maybe it'll move to a different ecosystem. So in that case, the carrying capacity is 50. There's only enough resources for 50 frogs. There's lots of extra food and lots of extra oxygen, and that's probably going to be used by a different population. But there's only enough space for 50, so you can't go above 50, or else someone will die. Here's another example. These are rabbits. They're living in a field. And this particular field only has enough food for 30 rabbits. It has enough space for 50 rabbits, and it has enough oxygen for 100 rabbits. What's the limiting factor and the carrying capacity? And here's your choices. So I want you to remember this. The limiting factor is always a factor, and the carrying capacity is always a capacity. A capacity is always a number. So what factor? It can't be a number. The limiting factor has to be a factor. What's the thing you're going to run out of? Well, your choices are food for 30, space for 50, or oxygen for 100. What do you run out of first? I think it's obvious you run out of food first. You only had enough food for 30. Now, what's the carrying capacity? It's going to have to be, in this case, 30, because you run out of food after 30 rabbits. If you had 31 rabbits or 60 rabbits or 200 rabbits, they ran out of food, and the extra rabbits have to either die or move someplace else. So look at this graph. In this graph, we're looking at a population. And like I said before, the population usually does not do dramatic things like this. Usually it just kind of hovers like that, up and down around this dotted line. And this dotted line in this case is the rabbit population. And if you read the label, it says rabbit population in thousands. So the shape of the population line tells us the story of what's happening to the number of individuals over time. Most healthy populations oscillate, go up and down around the carrying capacity line. So usually they go up and down and up and down and up and down like this. In this graph, this is supposed to be squirrels. So there was squirrels that moved into an area and they quickly increased. And what happened was they went above the carrying capacity. In this case, let's pretend they ran out of food. So some squirrels had to die and fewer squirrels were born, and now they're down below the carrying capacity. And then eventually more were born, and then they died, and they were born and they died. So they usually just stay around the carrying capacity. That's everything you have to know about this section.